Algebra 1 skills number 42, exponential models, as we enter kind of exponential world here. All right, so the exponential templates looks like this. Okay, exponential is when you have a changing exponent. There's a variable in the exponent. And on the formula sheet, you may not see this 1 plus or minus r, but it's important to break it down to this to kind of understand what's going on. A is where you start. That's the thing that you're going to multiply by something over and over. Okay, so you're going to start with a certain value and you're going to multiply that value by the same thing over and over. R is the rate of change presented as a decimal. It's usually given to you as a percentage. You want to change it to a decimal for this position. And T is your time. This 1 represents the 100% of A that you start with. And you either add to or take from that 100% to watch the original value go up or down, depending. Okay, so some examples. A town has a population of 5,000 and grows at a rate of 6% per year. Here's our model. Notice what we put in here. 5,000 is the original. We have 100% of 5,000. We're going to add to that, and something within context will let you know, are you adding to or taking from. R is 0.06. Remember, it's given as a percentage. The percent symbol literally means divide by 100. So it's 0.06. Move decimal 2 places left. And then T. Okay, this would be the model. Okay, the model leaves T as a variable, and then you can use that if you want to know the population of the town at a certain value. So this is called the model. When we filled in A, we filled in R, we've added or subtracted. This is our model. Okay, how many people will there be in 5 years? We just simply insert a 5 in the T position, and it tells you 6,691. And make sure that makes sense. You're growing, so it should be more than 5,000, but 6% is a relatively small percentage, so you shouldn't grow too much in that amount of time. A second example, a truck worth $40,000 depreciates at 8.7% per year. Okay, again, our model, this time we're subtracting. Okay, depreciates means loses value. And notice again, we moved our decimal 2 positions to the left. Okay, so here's our model. And ideally, we should look at this and know that, okay, we started with 40,000. Each year, it's 91.3% of the previous year. That's the effect of losing 8.7%. And again, our model leaves T as a variable. How much will the truck be worth in 6 years? You just put a 6 in the T position. And again, it should give you a number that makes sense. That it lost value, and over 6 years, it's down to 23,167. Okay, if you lose 8.7% 6 times, now I have to be careful. It's not the same thing as losing 8.7 times 6 because each year the value changes. But that would be roughly half in this, so this number should make sense. Okay, again, here's your model for that. And we have a table. Sometimes you can go, we took this out of Desmos, but sometimes the table is a good place to look. Okay, and by using the table feature, you can see the truck originally was 40,000. 1 year later, it was worth 36, and so forth. Note also that with money, you always round to 2 decimal places. Here it rounded to 3, but that would be more appropriately 49 cents. So the table is sometimes a good place to look as well. A third example mentions doubling. Now, when you double or triple or quadruple, you kind of abandon the formula we've been using, but it's the same concept. You're multiplying this time not by percentage increase or decrease, but by 2 over and over. So keep that in mind. We start with 180 views for a video. So here's the model. Again, we're going to abandon this. We're not going to really think about it this way. We're just going to think this sort of collapses to 2. Technically, you're adding 100%, but people don't think of it that way. When you're doubling, you're just multiplying by 2 over and over. Again, we start with 180, you're multiplying by this, and this is your model. And you could use that model had it asked for the amount of views after a given amount of time. Exponential models.